Hello, I'm Tom Zellebor, CEO of the Space Foundation, and it's my pleasure to welcome you to Space Foundation Presents, our webinar series that showcases the missions and leaders that are pioneering new opportunities here on Earth, in orbit, and beyond. Today's program will focus on the next giant leap we'll be taking to the red planet Mars. There could not be a better day to hear from our very special guests about this new adventure. Exactly 51 years ago today, the world watched NASA astronauts Neil Armstrong and Buzz Aldrin take humanity's first small steps on a world that was not our home. 51 years later, we have three nations, the UAE, China, and the United States, all taking their own giant leaps to Mars with multiple spacecraft. And by the way, congratulations to the UAE for their successful launch yesterday. While this is a source of great national pride for each of these nations, globally, we can celebrate what humanity can learn and achieve when we invest in people, curiosity, and pursue bold, challenging frontiers. At Space Foundation, that is part of our mission. We are looking forward to bringing the world's space community together again at the 36th Space Symposium this coming October 31st through November 2nd. Both in person in Colorado Springs and virtually. We are also doing our part through our Center for Innovation and Education to drive diverse workforce development and economic opportunity so everyone can find their place in the growing space economy. At no other time in our history have we seen anything like what is unfolding with these three unique missions to Mars. Each of them is a science and engineering marvel, but today we want to specifically call out the NASA and JPL team for building another remarkable rover, the Perseverance, that will kick up even more dust on the red planet, but also for building the aptly named Ingenuity Mars helicopter, the first aircraft to attempt controlled flight on another planet. And let me personally add from this retired naval aviator, to those who will fly Ingenuity over the landscape of Mars, your flights and performance really will change the universe, and we can't wait to see what we learn from this. The missions of Perseverance and Ingenuity, along with Mars-bound spacecraft from the UAE and China, could not be happening at a more important time. As the world continues to fight COVID-19, missions like those going to Mars give us hope and inspiration for the days to come. The mission teams behind this new round of visitors to Mars have certainly done their part to adapt to this difficult environment and lead by example. So to each of those team members at NASA JPL, the ULA Atlas team, and the UAE Space Agency, and the China National Space Administration, on behalf of the Space Foundation and the global space community, thank you for your courage and character and showing us all that pioneering never stops. Today's webinar is part of our ongoing series called Space Foundation Presents, which is co-sponsored by Boeing. It's another example of our mission to bring you, the pioneering leaders that are making our universe more accessible to everyone, and we are grateful to Boeing for their support. To make sure you can be part of today's conversation, we are taking questions via Twitter using hashtag AskSF. And with that, it's time to begin our program. Joining us today is the Honorable Jim Bridenstine, NASA Administrator, and like me, another proud naval aviator. He is also a former member of the U.S. House of Representatives, having been elected to serve the 1st District of Oklahoma 3 times. Also part of today's program is Dr. Thomas Zurbuchen, NASA Associate Administrator for the Science Mission Directorate. We also have Dr. Michael Watkins, Director of NASA's Jet Propulsion Laboratory, and finally, Ms. Mimi Young, who is the Project Manager for the Ingenuity Mars helicopter out of NASA JPL. It's an honor to have them join us today. Now, before I turn the program over to Thomas Dormy, Space Foundation Vice President of Washington Operations, to moderate the discussion, we have a short video highlighting NASA's effort. It clearly shows that despite the challenge, NASA continues to inspire a nation and future generations of exploration. The video is appropriately titled, "We Persevere."
We are a species of explorers, believers.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard.
We are willing to do the hard things to overcome the many challenges. This is what brings out the best in us.
We go for a mission to the moon.
Our path has led to success and to bitter losses.
We come together today to mourn the loss of 7 brave Americans.
Yet, even when faced with tragedy and setbacks, we persevere. We keep striving. We keep believing. From space, we see our planet as a whole. We see the challenges facing it, and we face those challenges together. We will not give up. We challenge convention. We refuse to accept the status quo. The time at hand is hard, but we will persevere. We can still draw hope from the moon and the stars, from space, from exploration. There is a new day beyond the challenges we face now.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans.
10, 9, we have ignition sequence start.
But if rovers are to be the qualities of us as a race, we missed the most important thing.
3, 2,
Perseverance.
launch commit, liftoff. We have liftoff.
We are a species of explorers. We will meet many obstacles on our way to Mars. But as humans, will not give up. We will always persevere.
Wow, that was an inspiring video. Hello, I'm Thomas Stormy with the Space Foundation. It's my privilege to moderate today's event and our live discussion with NASA leadership. I want to invite the NASA team to join me on our virtual stage, and in order, if I could ask Mr. Jim Bridenstine, the NASA Administrator, Thomas Zurbuchen, the Associate Administrator for NASA's Science Mission Directorate, Michael Watkins, Director of NASA's Jet Propulsion Laboratory, and Mimi Ung, the Ingenuity Helicopter Project Manager, to join me. First, as we get started, Administrator Bridenstine, I want to thank you and your team for joining us here today. And I have to say, that was truly an incredible and inspiring video.
Well, thank you. And I just want to say thank you to the Space Foundation. This is a relationship that I've had with your organization that goes back to my days in the House of Representatives, and the great scholarly work and the studies, and of course, the committees are putting together as it relates to space. And it really has been a real pleasure working with the Space Foundation for all of these years. And of course, as the head of NASA now, it's a relationship that I see continuing long into the future. So thank you for your great work, and thank you for hosting this.
And thank you. And we do have a great, strong relationship and look forward to keeping that going in the future. So we're going to begin with some opening comments from NASA, followed by a question and answer session. As a quick note for those that have joined us and are watching live, feel free to join the conversation and ask a question using our hashtag AskSF. So now let's begin, and I think we're going to start with some comments from Dr. Zurbuchen. So Thomas.
Hey, thank you so much. I'm so excited to be here with the team. Before I get started, I wanted to congratulate the United Arab Emirates for their successful launch of the HOPE mission to Mars. Along with their Japanese launch partners, that's a truly amazing accomplishment, and we're happy to join them soon with Perseverance, because together, hope and perseverance are essential ingredients of exploration. It's truly an exciting decade ahead of us as the entire world sends missions to Mars to study and explore the red planet. Next week, the United States returns to Mars. It's the next step in putting together a puzzle we've been working on for centuries, which has accelerated in the last 55 years, beginning with the first flyby of Mars by Mariner 4. The world's eyes were opened when the Viking landers sent back transformative pictures of the surface of another planet for the first time. And the world got to see for itself the color Mars red with its own eyes. And we saw how it resembled our great American desertscapes. And we wondered anew what our two planets might have in common. Where all the ingredients necessary to life, carbon, other elements, water, energy, were they present on Mars, and had the zoo produced microbes as it did on Earth that did unhappy celestial occurrences for the neighbors snuff out that agent's life as we flourish here on Earth, as life is an important part of our planet. These are questions scientists have pondered for decades and more. So now we send Perseverance, the most capable robotic scientist ever sent to the surface of another planet, to the most promising place we could determine from here that could have supported life, an ancient river delta by what might once have been a huge lake. The Perseverance rover builds on the legacy of NASA's Mars exploration program and joins a fleet that right now includes a rover, a lander, and multiple orbiters. It's our 9th mission to land and our 5th rover. Perseverance is our first mission to have astrobiology, in this case, the search for ancient life, as part of its top-line science goals. That current fleet of Mars, including the rover's planet-made Curiosity, which is still roving 5 years in, and all the missions we have sent historically, these other missions have all found things that led us to keep going down this path, having found organics, methane, signs of water in the past, and even now, Perseverance suites of instruments will take the next step. Perseverance is also the bridge between science and human exploration that demonstrates how the two can support and reinforce each other. It will do incredible things until human scientists, with their own unique perspectives and ability to make science judgments, are able to walk the surface. I look forward to that personally, many of us do. And it advances a set of tools that have on the surface of Mars. While 55 years ago, we got a quick image as the spacecraft rushed by, now we can contemplate evaluating samples and collecting them and bring them back to Earth. So what will Perseverance do? The planet's story is told in parts through its climate, and Meta will tell us more about the weather on Mars and the prevalence of dust and how it affects human missions. RimFacts will probe beneath the surface, perhaps finding ice deposits human missions could use. SuperCam and MassCam will survey and study the environment and turn amazing images. Basically, Perseverance will bring all human senses to Mars. We'll sense the air around it, see and scan the horizon, hear the planet with microphones on the surface for the first time, feel it as it picks up samples into cache, perhaps even taste it in a sense as Pixel and other instruments sample the chemistry in the rocks and soil around it. As humans prepare for the greatest adventure here in person exploration of Mars, our robots can help. Moxie will help demonstrate how we might live off the land by converting carbon dioxide into oxygen that we can breathe, or for rocket fuel. Sherlock, in addition to searching for organics, uses spacesuit material for calibration, which will also help us learn how it degrades on Mars. And technologies such as MEDLI and Terrain Relative Navigation, TRN, will help our rover to the surface and also provide data that is important to landing future human missions on Mars. Jim is going to talk a lot about this and this important context of human exploration as well. A helicopter named Ingenuity will demonstrate powered flight on another planet for the first time. I really look forward to seeing this Martian Wright brothers moment. Mimi will tell us more about this. I'm just so excited about it. And Perseverance is going to prepare for humanity as long last to hold a piece of Mars in our hand, not just a meteorite from somewhere, but a piece of an actual surface with its geologic context, analyzed with the best instruments there for us to study back on Earth with the instruments as the best instruments humanity has available to themselves, not only today, but also in the future. This is the first leg of humanity's first ever round trip to another planet. And this amazing explorer could not have been ready for launch in this transient window we have without the perseverance of teams across the country and the world who struggled and sacrificed through the global pandemic to keep their sights on this milestone of humanity. Their work and this mission embody the agencies and our nation's spirit of persevering even in the most challenging of situations, providing inspiration and advancing science and exploration. And the mission itself personifies the human ideal of persevering towards the future. Mike is going to tell us more about this especially. Perseverance carries our hopes and dreams, the names of 11 million people from across the world who sent in their names to go with us under the plaque we read Explore as One. I just want to tell you, both of my parents who are no longer with us, their names are there. That is really meaningful to me from that perspective, as well as also my family who's here, who's all of their names are on this list. And Perseverance carries the goodwill of the entire space community that we and other nations all send missions to Mars this decade. It reinforces NASA's commitment to working with our international partners to accomplish stunning achievements in science, technology, and exploration. So when Perseverance launches, it takes us all. Every one of us will have a chance to learn from and be inspired by this mission. Anytime we attempt something that pushes us to the next threshold is a time to celebrate. It is a big moment, a milestone for humanity that we all share. We explore and discover together, and together we persevere. And with that, Thomas, I'm sending it back to you.
Hey, thanks, Thomas. Thanks for this. That was a really great overview. And I think it framed the importance of not just this mission, but what NASA, is doing at large with these scientific explorations. Now I'd like to invite Dr. Watkins from JPL to make some comments. Mike, over to you.
Okay, thank you, Thomas and Thomas. Exactly as Thomas Zurbuchen said, the name Perseverance, to a certain extent, it means two things. It means our rover, that's the most capable rover ever sent to another planet. It also means the 1,000 team members, or even more than 1,000, that built Perseverance and will operate it on the surface. And I'm going to talk a little bit about that team before we talk more about the machine. To make a mission like this be successful, to get it to the launch pad, to get it finished, to get it to Mars, it takes a lot of perseverance. It takes a lot of brilliant hard work in the best of times. And I don't think any of us anticipated this COVID pandemic. And right during the most busy time of the mission, so the time when we are working 3 shifts a day, 24/7, trying to finish up the final assembly, put the clean flight hardware on, do all the final testing, and make sure that we are ready to go. That's right when we were hit by the pandemic. And so what we have done, of course, is pull out all the stops and making sure that our team stayed safe. So that means lots and lots of telework. So lots of folks staying at home, just like everyone watching, trying to operate the test beds, trying to write software, trying to do lots of work from home. And then when they were in the office, when they had to actually get in there and touch hardware and assemble hardware, lots of PPE, lots of social distancing, and really, lots of mental stress. I think all of us have experienced that, but this team had it doubly. We have about 100 folks down at the Cape, at the Kennedy Space Center in Florida, doing the final assembly. That's where Perseverance is right now, and another several hundred at JPL, working on the final testing and in some cases the final hardware that we shipped out to KSC just recently. Those folks not only had to deal with having sometimes family at home and that kind of stress. In some cases they were separated. Sometimes they had to self-isolate or they had to be quarantined. And they couldn't have the normal de-stress behaviors. And so I really just cannot say enough about how incredible this team was. As I mentioned, it is a heroic effort, in the best of times. And this team really knuckled down and completed this really on schedule, and we are ready to go. And I will acknowledge, not just the JPL team, but of course the ULA launch team, a lot of our instrument folks, and the KSC team as well. So it's really a team effort. I'll also say that the NASA as an agency really came together as a family. We were in terms of transporting people, transporting critical hardware out, and really it's just been a surprisingly smooth experience given all the troubles with COVID. And so, here we are basically at the pad, ready to go. And so, we intend to launch at the end of July, and we will get to Mars in February. Now, when we get to Mars, we're headed for a landing spot, Jezero Crater. Now, the scientists have pored over every image of Mars we have from Mars Reconnaissance Orbiter and characterizations from the XRISM instrument and others in terms of what is the best site on Mars that had ancient habitability, we believe had ancient habitability. We learned a lot from Curiosity at Gale Crater, but also can preserve signs of that habitability, maybe signs of biosignatures if they existed. And so the scientists selected a Jezero Crater. It is in fact a crater on Mars. It has a river delta in it. It looks just like a river delta that you'd find on, somewhere on planet Earth, but it dried up about 3 billion years ago. So we are looking for ancient biosignatures. We're looking for the best spots on Mars. It's a clay-rich environment where these signs could have both formed and then been preserved. But of course, when we land, even with our great landing system and with our terrain relative navigation, we touch down somewhere in our landing zone, our landing ellipse, we call it. And then our scientists have to find the very best spots, right? They've got to find those gems, those pots of gold that are there that represent this critical habitable environment and possible biosignatures as well. And that is where the mission again becomes a human and machine mission together. It becomes a partnership between robotics and humans. So, we've talked about the complexity of Perseverance and how that helps us understand how to send humans to Mars later. It helps us understand the long delay in communications, helps us understand navigation, helps us understand landing systems, helps us understand in situ resource utilization. So all of these help us understand how to send humans to Mars. But even with our robot there, we still have humans on Mars. Because as Thomas said, it's our eyes and our ears, right? So we have the world's best team of planetary scientists, of Mars experts, and they direct that rover. And personally, having worked on Curiosity, having led the surface team for Curiosity, I think the most fantastic thing about these missions is that you land on a new Mars, and then almost every day, it's another new Mars, right? Every day you drive a few hundred meters and you look around and you see something fascinating. And we actually release those photos to the public as soon as we get them. So when you get up in the morning and you click, on the Mars website, on the Perseverance website, you'll see the pictures about the same time that the scientists do. And it is just fascinating to see, where are we and what's the best place to go. And our scientists actually then interact with the rover engineers, with the instrument teams, and actually decide, that place over there, that looks like something I've seen on the Earth, and that had a microbial mat. Or that's an area that I've seen on the Earth, ancient preserved organics. So let's go over there and let's sample it. And we have a fantastic set of instrumentation. We can detect organics very strongly with some of our instruments. We can use X-rays, we can use ultraviolet, we can use a whole range of things besides cameras to really hone in on whether these are the right sites. And then when they are the right sites, of course, we have this fantastic coring machine that goes in, collects a sample of that rock, seals it up in a tube, and later we're going to go bring it back. And that's, as Thomas said, that's the first step in our round trip for Mars sample return. So really this mission, we're out there trying to find something we've never found before on another planet, and then we're trying to capture it and isolate it and bring those samples back to take a close look at them, much like they do with the moon rocks. Now, because we don't really land on Mars that often, so this is, we've done it 8 times. This is our 9th, hopefully be our 9th successful landing. We use these advantages on the surface to also test out new technologies, right? We want to keep pushing the envelope forward of what we are capable of on the planet Mars. And so in this case, we carry a couple of technical demonstration experiments, and Mimi Ong is going to tell us a little bit more about that. So Thomas, let me kick it back to you.
Yeah, Mike, and thanks for that. I mean, you really highlight the complexity, but also the team effort from start to finish, not just now, but once we land on the planet. And it's really great to hear how the public can follow along through that whole process. So that's amazing. So yeah, let's hear from Ms. Ong, who is leading the effort with the Mars Ingenuity helicopter. Mimi, over to you.
Hi, yes. Thank you, Mike. Thank you, Thomas. Thank you for having me here. It's really exciting to be here. As Mike mentioned, there are 3 technologies being demonstrated on Mars 2020. The terrain relative navigation for safer landing and has spacecraft in orbit and rovers roving on the surface. In the future, there'll be astronauts on the surface. And the helicopter can serve as scout for rovers and astronauts. Helicopter can also allow us to reach places that are simply not accessible today without being able to fly. So yet a tech demo on Mars helicopters never done before. Why? It's not easy to build a rotorcraft to fly at Mars. So the atmosphere is really thin. I mean, compared to Earth's, it's about 1%. So a vehicle to fly in Mars has to be really light, and it has to, spin really fast. So for this technology demonstration on the Mars 2020 opportunity, the helicopter we've built is named Ingenuity. And Ingenuity has a rotor system that's 1.2 meter in diameter, and the entire vehicle has to weigh under 2 kilograms. That's about 4 pounds. So to build this vehicle that weighs about 4 pounds, while having the capability to fly and land autonomously and to survive and operate autonomously at Mars, right, remotely operated from Earth, that's a huge challenge. It's a tiny package with tons of capability packed. So to build this, there is a significant team behind this team. And I wish really our team, I'm here to represent our team. I wish everybody on our team could be here to share the stories. We really have so many, everyone from different disciplines involving from the fundamental mathematical equations to mechanical, electrical, software, thermal, avionics, materials and processes, and even the special test equipment and facilities that it takes to build and test something for the very first time. So everybody in each of our discipline really had to reach out of the box, excel in our own discipline, and really work truly as a team, all to pack all of this into this 1.8 kilogram, 4 pound limit. And the day our vehicle weighed in a hair under 1.8 kilogram. That was a huge day for us. So since then, we've performed the helicopter test flights in a simulated Mars atmosphere in the 25-foot diameter space simulator chamber here at JPL. We've performed test flights and compared the flight performance to the mathematical models that we started the design with originally. We've tested the vehicle in simulated thermal environment, dynamics environment. We have tested it with Perseverance rover. And very importantly, Perseverance has tested deploying us from the belly pan of the Perseverance rover successfully to the surface. So at this point, we've performed all the tests that we can on Earth. And the next step really is now to do it in the real environment this Mars helicopter Ingenuity is designed for, in space vacuum, as soon as after launch, and finally on the surface of Mars. So at this very moment, Ingenuity is accommodated on Perseverance rover, waiting for the upcoming launch. And after Perseverance rover lands on the surface and has done the rover checkout, the rover will deploy the helicopter to the surface of Mars. And from then, we have a 30 Martian day window to do our flight experiments. So we have up to 5 flight plans to be performed in that time period. And the first and foremost, the most important flight for us, for our team, is the very first flight where we'll repeat the flight that we have tested multiple times in our test chamber here on Earth. So doing that in situ at Earth, in situ at Mars, in the Mars environment will confirm the algorithms, the tests that we performed on Earth. So, and then after getting that first flight, then we will be performing more bolder and bolder flights of higher heights and further distances. So here we are, exciting days ahead. Helicopter is about to be launched. Our team is thrilled. It's truly the high risk, high reward phase of our project. High risk because every step forward, starting from launch, every event that we have will be a first time event, right? First in space vacuum and then in the environment of Mars. But more importantly, high reward because, our algorithms and the tests that we have done on Earth and really then, operating in situ and learning from how to operate the very first rotorcraft vehicle in space from Earth. All of that experiences will be feeding into future, much more capable rotorcraft that we envision, and really add that aerial dimension to space exploration. And for our team, that is the ultimate reward that we've worked really, really, really hard for. So along that lines, while I have the opportunity to be in the same virtual room with you, Jim, Thomas, Mike, I really want to take this opportunity on the behalf of our team for having been there for your unwavering support through these past years on taking on this endeavor. It's been really important, for us to have that unwavering support as we took on this really high challenge. And so finally, also, if I may, on a personal note, I came to NASA inspired for the opportunity to contribute to space exploration. And along the way, I also fell in love with making first of a kind capabilities work for increasingly autonomous advanced space systems. And here today is an example of that dream come true. Here we are on a historical mission, Perseverance, working on a tech demo, Mars Helicopter Ingenuity. Thank you so much.
Mimi, thank you. And I can sense your enthusiasm, which you show for the whole team with this tech demo. That's amazing. And I think we're all excited to help or to watch and see Ingenuity take flight. So thank you very much.
Thank you.
Jim, such a tremendous team. I mean, a team of experts and certainly plenty of accomplishments along the way. Would you like to share some thoughts with our viewers?
Absolutely. And Mimi, your enthusiasm is palpable. And I just want to say to all the young people that might be watching today, Mimi is a shining example of the hope that NASA brings to the world. Think of a young girl who was growing up in Myanmar during some really difficult times, who had a dream of one day coming to the United States and working for NASA. That is who Mimi Ung is, and now she is leading a team that will, for the first time in humanity, fly a helicopter on another world. So I just want to say this is a great. It really is. It's your story, Mimi, is a story of perseverance, and this mission that is Perseverance with Ingenuity as the helicopter is. This is emblematic of the greatness that comes from these kind of exploration initiatives. A couple of things that I want to highlight. Of course, everybody has said so much already, but I want you to think about for a second what we learned from two little rovers, Spirit and Opportunity. We learned from these two rovers years ago that the northern hemisphere of Mars was largely covered with water. 2/3 of the northern hemisphere of Mars was covered with water. We learned that Mars at one time had a very thick atmosphere. And so it likely also had a magnetosphere that protected it from the radiation of deep space. In other words, Mars was at one time habitable. I'm not saying it was inhabited. Nobody knows. I don't know, neither does anybody else. But at one time, it had the ingredients necessary for having life even on its surface. And now we think about what we have learned because of Curiosity and some of our international partners. We've learned that Mars has complex organic compounds on its surface, all over the surface. So the building blocks of life actually exist on the surface of Mars. They don't exist on the moon at all. but they're all over the surface. We have learned that the methane cycles of Mars actually match the seasons of Mars. So the probability of finding life on another world just went up again. And we have now discovered that what we believe to be liquid water 12 kilometers under the surface of Mars. What do we know about liquid water on Earth? Wherever it is, there is life. Is that true maybe on another planet? We don't know, but we need to go find out. And recently we have seen plumes of methane coming from Mars that increase the probability of finding life even more. These are very, very exciting times for a mission like Perseverance and like Ingenuity to help us make even more discoveries in this effort. And when we think about the Jezero crater, which Mike talked about just a few minutes ago, yes, we believe at one time the Jezero crater was a lake bed. But if you look at where we're going on the Jezero crater, we're not just looking for a dry lake bed. We're looking at what filled that lake bed. And what we have is we have a river that at one time flowed into the Jezero crater, and a river delta that where there could be, again, I'm not saying there is, but there could be signatures of biology from an ancient past. These are the things that we need to look for. And if we look at the rocks, the Mississippi River Delta, for example, we look at the rocks and the sediments, we can find biosignatures of ancient life. And can we take that, what we understand from our own planet, and learn from Mars and make determinations as to whether or not there was or was not life there? But I think more importantly is we're going to cache samples. We're going to go to those places where we believe have the highest scientific value. And we're actually going to cache samples for a Mars return mission that we're going to do in 2026, where scientists, American scientists and scientists from around the world are going to be able to look at those samples and make very specific determinations about the history and the formation and the evolution of Mars, and again determine whether or not we believe there could have at one time been life on Mars. So these are such exciting times. But I also want to say that all of these robotic precursor missions are leading up to something that I think is even more magnificent, and that is to a day when we plant an American flag on Mars. This is in the President's Space Policy Directive 1. He wants us to lead an effort to go to Mars. And he wants us to lead a coalition of international partners, and he wants us to go with commercial partners. He wants us to go to Mars in a way that we've never done. Well, obviously, nobody's ever gone to Mars. Certainly, we've gone to the moon. But when we think about the Moon to Mars program that NASA has initiated, we're going to the moon in a way that we've never done before with commercial and international partners, and we're doing it with a purpose. How do we live and work on another world for long periods of time so that we can go to Mars, where we will absolutely have to live for long periods of time in order to do what we need to do on the surface of Mars? The moon is the proving ground. Mars is the destination. So with the moon program to Mars and the robotic precursors, all of this is leading to a day when we have humans living and working not just on the moon, but on another planet, in this case, Mars. So the future is very bright. There's lots of opportunities. NASA's budget is as high now as it's ever been in history in nominal dollars. The budget request now before the House and the Senate takes it up even more so than it is right now, but it's intentional. We are building what is necessary to make more discoveries, learn more about our own solar system, learn more about our own galaxy and universe than we've ever been able to know before. So this is just a really, really exciting time to be at the helm of this storied agency that is making history every day. And this mission is yet another example of that history in the making. So Thomas, I'll turn it back over to you, but I'm certainly here for questions.
And thank you. And thank you all for those initial comments. So yeah, let's move into some questions and some discussion. And we're getting some good feedback in from our audience, so I'd like to try to get us through as many as I can. So Jim, I want to kind of start with kind of where you left us. I mean, it is this idea about both NASA, what it's done historically through JPL, NASA and its partners, these inspirational endeavors. So in these times, why is it important to continue these exploration missions? I mean, you highlighted on some of the specifics of this mission, but how will this inspire a nation? And more importantly, how will it enable the next generation of Mars exploration?
Yeah, no, that's important. You know, there was a 7th grader, and you guys had him in the video at the beginning. Alex Mather, who's the one who named the Perseverance rover. And I think it was a perfect name at the time. And of course, it's more important today than it even was when Thomas Zurbuchen came to me and said, hey, here's what we want to do. We want to name it Perseverance. We've got the 7th grader's name's Alex Mather, and he wants to name it this, and we think it's the right name. And of course, at the time, I said, sounds great to me. Let's do it. And that was before the coronavirus pandemic broke out, which of course has wreaked a lot of havoc, and of course it's made everything challenging for everybody. But again, the Perseverance mission is about persevering. And when we think about, we think about a 7th grader that named it. We think about probably a 5th grader, a 4th grader. Who are the people that are going to be inspired by these monumental achievements? And what is it that they're going to do and become? Like, how are they going to live their lives? This is about inspiration. And it's about bringing the nations of the world together in a very meaningful way at a time when, there's a lot of geopolitical challenges in the world, and yet space exploration brings people together in a way that I think is inspirational in and of itself. And I would also say that there are some very specific challenges when it comes to Mars, where we have a short window of opportunity every 26 months. To launch something to Mars, and if we didn't move forward with Perseverance, our Perseverance rover would go into storage for the next 2 years, and of course that entails a whole host of risks in itself, and of course it costs $500 million. So there's a lot of reasons to move forward with this mission. I will tell you, when I look at what Mike Watkins and his team at JPL have done, when I look at what Tory Bruno and his team at United Launch Alliance, what they have done, Thomas Zurbuchen and his team at NASA, we have done everything in our power to make working as safe as you would be if you were at home. Whether it's dividing up the shifts, whether it's the personal protective equipment, all of these things, social distancing that we have to do in order to keep this mission on track, we have done. And we've done it with great success. So I just want to say thank you to the team that has enabled it to happen. But I do believe, without question, we do need to persevere in these challenging times.
Thanks for that. It's funny. I mean, in light of everything going on, such an appropriate name, Perseverance, and really, and for those that have not had a chance to see Alex Mather's essay, I mean, it's just from a young man. That's a young teacher leader. That's an amazing name.
Thomas, this is Mike Watkins. I wanted to just add one thing in terms of inspiration. After we land, that's the beginning of the mission, right? We all celebrate that we landed, but really that's the beginning of this journey of discovery on Mars, and we share that with the public every day. So everybody can go in there, every school kid, every person can go and take a look at what's happening today with the rover, what new discovery was made today, and there are discoveries coming constantly. And to me, that's a fantastic way for folks to follow along and really get pulled into the space program and get pulled into, sometimes we anthropomorphize our rovers, but there's also a fantastic human team working those. And I think really that's something that folks can just live along with the mission. It's unusual.
Yeah, Mike, that's a great, I think we see it today. We've got such a large audience. I think we got 2,000 people right now following on Twitter and NASA TV and a variety of things. So people are certainly following along, and I'm sure they will. Let me, similar question on kind of why now, but a little different angle. This question actually comes from our co-sponsor, Boeing, who is sponsoring our series. The question is with Curiosity and InSight still active on Mars, why send Perseverance now? Why is now the right time? And what are the benefits of returning with a new probe so soon? We kind of highlighted that, but Thomas, I'll throw that over to you. Your thoughts on that question?
So first of all, I do think it's the ideal time. Frankly, it would be and Mike may have a different opinion, and I invite him, of course, but it would have been very difficult to kind of imagine doing this 20 years ago, frankly, or even 10 years ago. The instruments that are currently there and are sitting on top of the rock, together, of course, with Mimi's treasure, ingenuity, right? They're the best that we can do now. I really, and I think, together with the Academy's endorsement and encouragement, we know this is the most important question we could address right now. Going there, we're really lucky that Curiosity is there and is continuing to do amazing research. Don't think of those things as missions that somehow step on each other's feet, right? The Curiosity mission is continuing to do amazing work, for example, focused on organics. There's a new work that just recently came out. I know just recently being in touch with the mission team, there's new insights that are coming from there that are also informing what's going on with Perseverance. What is unique, though, about Perseverance, and the reason we wanted to do it now, is we can't wait to get those samples back, because the questions that we want to address now are really so much different than the ones that 20 years ago we might have asked. The questions we want to address now, we'd like to have these samples in our labs now. But Mike, how would you have answered it?
Almost the same way. I think it is clear, we wanted to first understand the history of Mars. We wanted to follow the water. We wanted to find a habitable environment. We've done all of those things. So from the scientific perspective, it's about astrobiology now. It's about, these complex organics, what's their history? Can we find them preserved? Can we find biosignatures? I mean, this is really the next step. I mean, it's where we want to go. It's where the program's been building up to at this point, and that's recognized by the Academy as well. I would add one other item beyond just the engineering knowledge and maturity that we've gained through these missions, and that is that we're not alone on Mars. In fact, we rely heavily on orbiters to relay our communications. So we can get much high bandwidth. Our videos are these beautiful panoramas you see. Those all come back from the rover talking via UHF, for example, to Mars Reconnaissance Orbiter or to MAVEN or to European missions. And then those are relayed at high rate back to the Earth. And so actually going back and doing sample return while we have that infrastructure in place, and we don't need to rebuild and replace that entire infrastructure of COMSATs basically and of photographic reconnaissance satellites, is another efficiency that I think is really worth it to take advantage of that really significant investment in building that infrastructure, both engineering and even budget-wise.
And I would say Curiosity and Perseverance, Mike and I were talking earlier, we think about the total landmass of Mars, it's equivalent to the total landmass of the world when you take away the oceans. Imagine if you were to study Earth for the first time and you landed in maybe Northern Africa. And from that, you made a determination as to what the rest of the Earth was like. You would miss a whole lot of things. So it is a big planet. There is a whole lot to learn. And yes, these missions don't step on each other. They really do complement each other. And we're trying to understand a whole lot more than just, one footprint on a really big planet.
So let me probe into that one a little bit. And no offense to anybody, but Mimi, your initiative seems to be getting the most questions. So I'm gonna, Mike, both for you and Mimi perhaps. So JPL has long been a pioneer of space exploration and innovation. So the question on Ingenuity helicopter, can you speak more of the challenges? So I'm actually going to kind of throw some of this out there that I get from the questions. The challenges in the absence of atmosphere for aerodynamics, guidance, and control. And then the next question, kind of as a rapid fire, just to let you get this out there. With less gravity and the possibility of extreme Martian wind, are we able to overcome these challenges for UAV? And then the last thing as part of that is if the first 5 flights are successful, will there be time, energy to be able to do some more?
Okay, I'll start it off. So definitely the challenge, first and foremost, is of course that lightweight, beating down that capability. And the way we addressed it is really removing all the traditional walls between the different disciplines that we tend to have in much larger, systems that we traditionally have. So we really had to learn to work together, starting from this aerodynamic challenge, optimizing the lift, even the way the blade, how can we maximize the lift, to how can we build that blade that is still light. It has to be very light, but it has to be strong enough. It has to be able to spin enough. And all the walls between aerodynamics and GNC and the power, the thermal, the structure, all of that really had to go away because we were really forced because of this mass constraint. So that's the very first, answer is that it really has been it's an engineering project, a dream engineering project to say. And then in terms of the atmosphere, we worked with the scientists way from the very beginning in terms of understanding the atmospheric densities and the winds. And we did take the scientists' knowledge of the Martian winds and built the helicopter. The response rates of the blade control systems and all of that are sized to exceed with margin the expected level of winds that we expect. So to add to that, in parallel to inventing this first helicopter to fly, so light and so capable, and we talked about autonomous, it has to survive autonomously and, be able to keep itself warm and that capability. We also had to invent in parallel the test system. We've never, built an aerial vehicle for Mars. And so parallel to inventing the helicopter was parallel system to invent the entire test system. How do you, after building the vehicle, it's not like we take it to a chamber and say, now let's fly it, right? We really had to incrementally check all the assumptions that we made in our models and carefully check it off. So there was that invention. And then there's the third leg that we don't talk as much about, which we should hear, is how to get it to Mars. The Perseverance rover team did an incredible job accommodating. Now that it's all working, it looks easy. There it is sitting on the belly pan. But the helicopter is one of the most tedious things to accommodate on the rover. And the rover team put us in a really nice location on the belly pan. And to minimize protrusion below the belly pan, the two teams worked together, the rover team and the helicopter team. We figured out how to put it on the side. On the helicopter, we had to adjust, some of the features. And there it is, accommodated and able to deploy. So quite a lot of innovation all in one effort.
So, thank you, and I noticed that that's a copy of the Ingenuity behind you. Very
full scale.
Yeah, exciting.
Yes.
So we've got a little bit of time left, and I want to get to a few other questions. So, Administrator, this is kind of more directed to you. China and the UAE are also sending spacecrafts to the Red Planet this month, and what we noted earlier, UAE's successful launch of the Hope Orbiter earlier or yesterday. What are the opportunities for NASA to collaborate on these type of initiatives? I know you're heavily partnered on a lot of others, but how can we collaborate with the national partners for Mars exploration or other places beyond that?
Yeah, it's an important question, and we do that quite frequently throughout all of our programs. And as a matter of fact, we have right now over 700 agreements between NASA and other space agencies throughout the world, and even other countries that don't have space agencies yet. We encourage everybody to get a space agency because we want them to be able to partner with us on our big missions. But NASA is a great tool of diplomacy. It's a great tool of bringing nations together. Here in just a few short months in November, we're going to celebrate 20 years of American astronauts and Russian cosmonauts living and working together in space on the International Space Station. And of course, while that's 20 years working together on that project, going back to 1975, we had the Shuttle Mir, the Shuttle Mir program in the 80s. We had the Apollo Soyuz program in the 70s. So this is not new. And we like to think that, NASA and space exploration, it kind of transcends politics. Republicans and Democrats in the United States, everybody loves space exploration. It transcends geopolitics. And so I think this is really a great opportunity for collaboration. And of course, we do have many international partners on the on Perseverance here. So it's a very exciting time.
So if I could, someone ask a follow up on that. I mean, you make some very persuasive arguments for what NASA deserves and the support, and it resonates across a large variety of people. So Courtney from Maryland sends this in. So, so clearly this resonates with space nerds like me, but what and how will you persuade your former colleagues in Congress who are facing large deficits exacerbated by COVID-related stimulus packages? And is there something that the private sector can do more to help augment your efforts?
100%. And it's, again, these are all important points. We think about what NASA has enabled throughout its history. We think about how do we communicate? A lot of people are going to watch this because they have internet broadband from space. Or if you're watching on NASA TV, you might have Dish Network or DirecTV. These are all space-based communication capabilities that were born from this little agency called NASA that was innovating at a level that was well beyond what anybody believed was even possible back in those days. But the way we do communications, over the horizon communications, XM radio, for example, we talk about how we navigate, GPS technology developed by NASA, of course now operated by the Department of Defense. But again, the way we predict weather, the way we do disaster relief, and a lot of the national security capabilities of the nation, the way we access space in general for a whole host of commercial remote sensing capabilities. There are so many things that NASA has contributed to on the economic side. We think about we're talking about Mars, right? Well, the camera in your cell phone was created because of a mission requirement that NASA had to create a really small camera when we explore Mars. That's just one of so many examples, but we think about the improvement of the human condition because of what NASA has been able to achieve. Right now, we're talking about JPL. They have a number of impressive missions. The GRACE follow-on mission, which is helping us understand where the drought is in the world, and EcoStress, which is enabling us to understand, can we increase crop yields while reducing water usage at the same time, feeding more of the world than ever before with less water usage. These are missions that NASA can do that nobody else, in the world is doing. So look, we are every day improving the human condition in ways that are absolutely immeasurable. And I'll tell you, as the NASA administrator, here's what I hear about. I hear about Tang and I hear about Velcro, which were two things that we, quite frankly, didn't invent, but we used back in the Apollo era. But I'll tell you, it goes so far beyond that. If you're looking for a return on investment, there is nothing better that the American government could invest in than NASA. And that's what's happening right now with bipartisan support. So it's really a good place to be right now.
That's great to hear. I have to apologize. We're balanced our time. I do have to ask before we go, Commercial Crew launched, just over a month ago, another historic thing. How are Bob and Doug doing, and how long till they return back to Earth on Dragon?
So Bob and Doug are doing fantastic. 3 spacewalks. Bob Behnken and Chris Cassidy have done 3 spacewalks. Of course, Doug has been inside the International Space Station supporting that from the inside. And now we've got 1 more spacewalk to go. And then they're going to be focused like a laser on coming home. And right now we're targeting a date of August 2nd for a return. But again, that's going to be based on a lot of conditions to include weather and sea states and other things. So we're targeting early August, but so far that mission has gone very, very well, better than expected. And I'm knocking on wood because it is not over until Bob and Doug are home. So we're in good shape there.
So I apologize. We are over time. Real quick, Administrator Bridenstine, any final thoughts before we sign off?
Sure. Thank you. And again, thank you to the Space Foundation and thank you to Boeing for hosting this. I just want to say this mission that we're about to launch is historic in and of itself. But what it's building towards is something even bigger. We're going to Mars as humanity, with international partners, with commercial partners. The first step to do that is we have to learn how to live and work on another world. And it just so happens that we have this moon that's a 3-day journey away. We learned in the Apollo program, Apollo 13 specifically, that things can go very wrong on the way to the moon and we can still make it home. Things could go wrong on the surface of the moon and we can still make it home. When we send humans to Mars, we have to make sure that we've got the architecture established, that we've got the systems proven. So we're going to the moon to learn how to live and work on another world so that we can get to Mars. And right now we're doing these robotic missions to Mars so that when our humans do go to Mars, we know where to go, we know what to do, we have the absolute best locations picked out where we're going to be able to maximize the utility of the science. So all of this works together. One of the things I've been working on ever since I've been the NASA administrator is wherever there's division, we need to drive it out. People used to say, well, it's either the moon or it's Mars. It is not true. We can do both, and we need to do both. People used to say, well, it's either human exploration or robotic exploration. It is not true. We need to do both. They work together side by side. So there's a lot of opportunity, and bringing everybody together is what's going to enable it to happen. And again, right now we've got strong bipartisan support. We're working every day to grow that. And anything people out there can do to help is what makes these programs sustainable. We need to think not just in terms of, administrations. We need to think in terms of generations. We need long-term sustainable programs that can go from one generation to the next. And if we do that, we will, in fact, be on the surface of the Mars in the not too distant future with humans.
So thank you, Jim. Thanks for that, and thanks for the inspiration that all of you bring. And thank you for joining us here today. This has been a great discussion and an honor to host you on our Space Foundation Presents series. So thank you.
Thank you.
Thanks. Appreciate it.
Thank you.
Thank you.
I also want to thank everyone for tuning in today, especially those that were participating using our hashtag AskSF. I also want to recognize our co-sponsor Boeing for their great support and for all their amazing initiatives across the space industry. As a reminder, this event will be posted online for later viewing at spacefoundation.org. Again, thank you for joining us. From all of us here at the Space Foundation, stay healthy and have a great day.